I know. Okay, so the last thing that I'm going to teach this week is trig derivatives. It's something that we have looked at before. I think these were the only ones that oh, we ran out of room on my screen. I don't know if this is like this on yours, but these top ones you guys saw during the calculus unit, but I don't know if I ever gave you the inverse ones. Do y'all remember?
We didn't ever go over those, I don't think.
We never went over those.
Yes, we did. No, we didn't.
No, we
We
didn't.
went over the function for function and wait.
We went over
These-
those, but we didn't go over
These sine and cosine,
Yeah,
the regular
yeah,
trig derivative.
we went over
Okay. Well, really, it's just memorization. So there are plenty of flashcards out there. I can double check what they give you on your formula sheet, but I think they only give you sine, cosine, and tangent.
Okay.
So
That's kind of rude.
yeah.
Can we just talk about the fact that we have to take our IB exams? But okay. All right.
Can you focus on class since you don't even remember the last two lessons instead?
I don't even think I was here.
No, you were.
Was I?
Yeah, because you had a lot of questions about it.
Oh, it was.
You fell asleep in my regular class. Yeah, I remember.
Oh wow. Okay, that makes sense.
Yikes, big yikes. Okay. So if you were to graph these and then look at the slope, that's why you come up with a different trig function. Do you guys remember looking at that?
No.
Okay, well, I'm going to pull up, let me just switch screens and I'll do one real quick. So much stress. Okay, let's see. If I pull up Desmos. When you graph sine of x, what is the slope here at negative pi over 2?
0.
And the slope here?
0.
So when we graph the function of cosine, look, its new point directly above this is 0. What would you say the slope is of the red function at 0?
1.
1, and that's the new point for the blue graph. So the blue graph, we're just plotting the slope of the red graph, and that just so happens to be the cosine function. So the second one is cosine of x. And when you graph negative sine of x, you get the slope, because the slope at the red point here is 1, or is 0, sorry. And then the negative sine of x is 0. Here, the slope looks like negative 1. So our new point is negative 1. I think it's beneficial to understand why it is, but really you just have to have them memorized.
Okay.
Yes. Keep in mind that you have to do chain rule with trig derivatives, meaning that on your notes page where it says cosine of u, du, so if this was cosine of x squared, sorry, this was cosine of x squared, then the function would be negative sine of x squared times the derivative of x squared, which is 2x.
Whoa.
Crazy looking.
Why?
Yeah.
Wait, can you explain why?
So chain rule, whenever you have a function of a function, you have to take the derivative of the outside and then the multiply it by the derivative of the inside.
Oh, UDU. I remember. Okay.
Yeah. Okay, so I have that up on Delta Math for you already. It's so interesting how y'all hadn't done your other homework either.
I did.
So, but make sure, even though I'm only assigning one problem, remember that that doesn't mean just get one problem right. Everybody remembers that?
Yep.
Because if you just try to do one problem, you're probably not going to do well on your test, which is going to be our first session when we get back from spring break.
So in 2 weeks.
Yep.
What?
And wait, is our test just gonna be on the stuff that we learned today, or is it gonna be on everything that we just learned?
It'll be on this, everything since you took your test. So it will be complex derivatives, disks and washers, and vertical revolutions.
I'm not sure about how I feel about discs and washers section.
So it'll be 2.1, 2.2, and 2.3. Okay. Does anybody want to see a complex derivatives problem?
Yes.
Heard a yes. Okay. Just make sure you're keeping up with this stuff. Yeah, okay. So let's look at one of derivative of E. So what is the derivative of E?
EUDU.
Okay, so really what that means is we're gonna rewrite what's already there. And then multiply it.
Oh,
times
by
the
the
derivative of
that,
what's in the
so that
top.
would be 10x to minus 24x to the third. Is that right?
Yep.
Yes.
I just seriously get something right. Okay, cool. It's early
Not
in the
too
morning.
bad, right?
I'm happy with that.
Okay, so one with base not E. So what would this one become?
Would it be 3 and then -6?
The 3 would go away, right?
So this is called exponential base not E.
Natural log?
It's a natural
So it'll
log.
start with the natural log of 3 times what's already there.
Oh, 3. Okay. Plus, and then plus x to the fifth. Okay.
Times the derivative of what's in the top.
Negative 6x to the fifth plus 5x to the fourth.
Hi. Mm-hmm.
Make sense to everyone?
Yeah.
So again, I'm just using that worksheet to write them down. The more you do these, the more familiar you'll become. But I would definitely spend some time with your with the formulas to make sure you're memorizing them too. You can check. Did I put on? Let me find it. Your formula sheet is on here. So for HL, for calculus, they give you tan, secant, cosecant, cotangent. So they give you those. They give you base, log, and all the inverses. So the only one they don't give you, looks like, is e to the x, right? And any of the cosecant, secant, and cotangent, which to me, I would have those memorized just in case. But honestly, I don't think they'll ask you for those bottom 3 formulas on your notes of cosecant inverse, secant inverse, and cotangent inverse. I think they're worthwhile to learn, especially if you're interested in going into a math field at some point. but luckily for you, they're given on your formula sheet. But notice that the way they write them here, they just have x. So you have to remember to do the u du part.
So why is it you multiplied, like, okay, you did the 3, ln 3 times 3, and then the whole thing again. So why did you do that? I thought, like, in derivatives, a lot of time you, like, disregarded the first. Like, I don't know, maybe this is something we always do, but I don't remember, like, having them multiply the whole thing again.
This isn't something we always do, air quotes. But these are complex derivatives. They're not just the -1 thing.
Okay.
Like normally you have a function that starts with x to the third plus 4x squared. And when you take the derivative, you would bring down the power. That's normally what we did. Those are called power derivatives.
Okay.
These are complex derivatives, so you're just using the formula that's on the right-hand column.
Okay.
Other places where we used chain rule, I think trig was the main place that we used it in your class, but we also did it for things like this. I don't know if you remember these questions where we were like, what's x plus 7 to the 7th power? Do you really want to multiply that out that many times?
No.
No. Let me change this, sorry. So instead, what we did is we did chain rule. So we rewrote this as u to the 7th power, and we took the derivative of that, which would be 7u
Sixth.
to the 6th power times the derivative of u. And so this becomes 7 times
2x squared plus 7. Oh, and okay. So then
times the derivative of the inside, which would be 4x. Does that ring a bell?
Yeah.
Yeah, there was the class where I wrote this on the board, and then Mikkel said, yeah, I'm going to multiply it all out.
And then he multiplied it all out.
Yeah, instead of listening to the rest of the lesson. Fun times. Okay, does that make sense to everyone?
yes.
Okay, so that's your homework.
Okay.
Yeah.
Can I go back to
All
sleep?
right. I'm getting started on that.
I wouldn't recommend going back to sleep because class starts in 20-ish minutes.
I'm gonna take a 15-minute nap.
I was about to say, that sounds like a fat nap right there.
All right, sounds like you're not doing your homework, but
That's fair.
The tough scene.
It sounds like your
Yeah,
effort
so
grade
I
is gonna
can't
go
even
down.
out for- Wait, could you go over the washers?
could I go over the washers?
Mm-hmm.
Because, you know, just reviewing, you know.
Well, I'm not the only one.
No, this is actually at Tomas. Okay.
Yeah. Morning.
Tough. All right.
Wait, Miss Thompson.
Even HL now.
Miss
HL.
Thompson.
What's up?
On my Delta math, I don't have vertical revolutions. You never added it.
It might have already expired because it was,
Yeah.
remember, you're supposed to be doing these Delta maths every single week.
Oh,
Yeah,
when
it was expired already. I
So
checked.
here it is.
I wanted to do it last weekend, but nope, it was already expired.
I can add it again. Let me edit it real quick.
Cool. Got that one right.
Okay, so I can add the disks and washers in a second too. So revolution's about a vertical line. So they're wanting us to find this region here between these two. Do you guys see where my mouse is moving?
Yeah.
Mhm.
Okay, so that region, if we took it and rotated it in a circle around this vertical line. Okay, so we need to find our radius. I don't know how to keep on switching back and forth to make this easier. First things first is you need to find your intersection points. So I set these two functions in terms of y into my calculator. So I would have y equals negative x. And we would also have, to solve this one for y, you would have negative x plus 2. But that's only 1/2 of it, so we also have to do the negative side.
How do we do square root on this thing?
You open up the keyboard on the bottom left, and it has the square root.
Ah, I see it. Okay.
How did you know that?
Well, I do delta math.
Not you, dumbass.
Darn.
Okay, so the first thing is to find these intersections, which are at -2, 2 and 1, -1. With me so far?
Mhm.
Yes.
Okay, so these are going to give us our boundaries, and remember that since we're doing things in terms of y for this one, because it's all vertical, our boundaries would be -1 and +2.
Mhm.
Okay.
Okay,
You
so
say
we're
that one
looking
more
at
time?
y coordinate because we're doing vertical.
Would
Okay.
you do the positive zero like? Oh wait, never mind. Go ahead.
Okay, so from there, we need to find our radii, and they give it to us in terms of x, which is already really helpful. Which one is further away from this dotted line in the area that we're looking at?
The
point?
negative x.
-2.2.
The function negative x, yes.
Negative x.
One -1.
No, just this function, this straight line.
Oh yeah,
Why?
the straight line.
The red line is further away.
How?
Because the
Okay,
curve.
if I got it. X equals 7, sorry. Okay, which is closer to this blue line, Liz? The straight line in this section, just this section that we highlighted, or the curve?
The curve.
Right, so which one's further away?
Oh, further away. Okay.
Yeah. So further away is our big R. So that means that this function, x equals -2 minus y squared, is our big R. And so for this, remember you're integrating. And you have the integral of pi big R squared minus pi little r squared. Yes, we remember that. No,
Yes.
we don't.
No, we don't.
Yeah.
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 Just me, I guess.
Okay, so
Miss Thompson, is there any way you could give us like an extra day for the discs and washers?
Yeah, I'll put it back up for partial credit.
Okay, well, is all of our HL gonna be due like the week after now?
It's always been that way.
Really?
Yes.
Hmm.
Okay, so our formula is the integral of pi big R squared minus pi little r squared. dr. Okay. There's a pi in both of them, and since pi is just a coefficient, I'm going to pull it out. So we have pi big R squared minus a little r squared in terms of whatever we're multiplying by. And so all of ours are in terms of y now, in respect to y. So we have pi integral from, what was it, -1 to 2.
Yeah.
And our big R was the curve, which was y squared plus 2.
Wait, wasn't our big R the one that was further?
Oh, yeah,
away?
just the negative x, my bad.
Yeah.
Negative x squared minus, is it y minus 2? Do y'all remember? It's 2 minus y squared.
So to find the when you got the negative x squared, you subtracted it from the given point in which it's rotated around, right?
Sorry, and it's supposed to be negative y squared because we're working in terms of y.
Could you go over how you found the negative y squared, where you got that again? I think I missed it.
Okay, big R, which, so just the negative y is the function that's furthest away. It's the straight line.
Okay.
Y'all still with me so far?
Should we just like automatically know how to look at like something and know the function?
What?
Like, should we be able to look at a line and just like automatically know that it's 2 minus y squared?
No, the function was given to you.
Oh, I didn't see that.
So I have a question, Ms. Thompson.
What's your question, Rohan?
On the discs and washers, you have the function. You have to subtract like another part of the equation from, I think, like the line that it rotates about. So why wouldn't you
Yes.
do that here?
You will. I just wanted to re-show the
Oh, okay.
just the first part, because what I'm going to do is add back in now the distance from, I just wanted to start there because I think people get confused when we start adding in the number.
Okay, that makes sense.
But yes, you are correct. I'm just trying a different approach since it didn't stick last
How
time.
do you get to the integral again after like on your calculator?
It's math. You should do math and then number 9, I think.
Okay.
I think I do from left to right for this one. So for the original problem, let me bring you back. Sorry, gosh, I'm trying to like switch between all these screens. Okay. So here we're finding the distance. The biggest radius would be from the straight line all the way down to this dotted line. Do you guys see that?
Mm-hmm.
So how do we find that distance?
You count the little box.
You could count the little boxes, but you subtract. So this would be negative y minus 7. So both of these are minus 7 will give you the distance.
Wait, what? Why would you do that? Isn't that just so much more work?
Okay.
Mhm.
So this would end up being pi times the integral of -1 to 2. And then you would type it into your calculator. So what I'm going to recommend, what I'll do you guys have an Irish time session coming up where you don't have something?
No.
All of our time sessions are booked.